Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is one MCQ about Cresol. I request you student, please pause the video, try by yourself and please write whatever answer you get in the comment box, because self-evaluation is essential for improvement and I want to know your status. Don't hesitate. And by the way, after some time you will get the explanation with mechanism. Now this is student a relatively easy question, so let's start. Now this reaction you can see have three parts. One is KOH dimethyl sulfate means DMS, second is 2-methyl propene and third is nitric acid. Before going to details, I request you student, please pause here and try to remember the structure or property of this dimethyl sulfate, 2-methyl propene and this reagent nitric acid acetic anhydride. If you are able to do this, the problem or became very easier. Now let's start. Mechanism. So first step is KOH dimethyl sulfate. This dimethyl sulfate is actually a electrophilic reagent because if you look at the structure of this reagent, this is dimethyl sulfate. So in this case OCH3, this is also OCH3. So this is delta positive, this is delta negative and this is delta positive. Now it can act as good electrophile. You may compare this thing with methyl iodide. Similar, delta plus, delta minus, and this after leaving means after this nucleophile means this O minus attacks. These bonds come here means this O minus is produced, which is resonance stabilized, means this by one is this way, another is by this way. Okay, so first stage is that KOH act as a base. It's a base, so it deprotonates the OH into O minus such that this Cresol becomes a better nucleophile. Then it attacks this methyl group and ultimately got converted into this ether. Okay, this OMe derivative. Now in the next step you see this reagent. This is 2-methyl propene. There I have written the name, here the structure. So in presence of sulfuric acid, what happens? Sulfuric acid is a very strong acid, means it produces H plus efficiently, and this carbocation react with H plus, this alkene react with H plus efficiently and produces one very interesting compound, tertiary butyl cation, and you can consider the H plus is here. Okay, why this tertiary butyl cation? Because this is very stable, so that's why it will produce from sulfuric acid. Now in this way we produce a tertiary butyl cation, and in the next step it will act as electrophile for Friedel-Crafts alkylation reaction. Okay, so in Friedel-Crafts reaction you have seen that aluminium 3 catalyst is used to, means in that case we use Rx plus Al3 plus. Why? Because this Rx is abstracted by aluminium 3 plus such that it can produce R plus, which is the actual electrophile. But in this way, based on our smart choice, not Lewis acid, we have used this sulfuric acid and produces this carbocation. It's a relatively stable carbocation, and that's how it can undergo the reaction. And now if you look at these reagents to this starting, this is electron rich because this oxygen lone pair makes this benzene nucleus electron rich and more efficient for aromatic electrophilic substitution. And we know this OMe, this phenolic derivative, is both ortho and para orienting. Okay, now remember in ortho position both minus I and plus R works. Now where minus I comes, because oxygen is electronegative atom, it has minus I effect, means sigma withdrawing, and that works in ortho position, but in para position only plus R works. So that's why para substitution is favored over ortho one if there is no other specific reason. So in this way, first through sigma complex formation and then aromaticity, it will produce this. And by the way, I am not explaining every step, student. I have already made dedicated lecture on these topics, aromatic electrolytic substitution. You may visit for better understanding. Now, in the next step, what happens? The reaction is nitric acid, acetic anhydride. Student, acetic anhydride is actually a dehydrating agent. So it dehydrates the nitric acid and produces this NO2 or nitronium cation, and this is actually the electrophile, and itself got converted into, means if you add water to acetic acid, then what it will produce? Water to acetic anhydride, it will produce acetic acid, or you can consider it will form then salt, means acetate. So that's why I told the word nitronium acetate. And in this case, this is the electrophile, so this will react. Now question, where it can react? See, our starting was this one, this derivative, and we know this OMe is orthopara orienting. Now the para is blocked by this tertiary butyl group, so reaction is expected to happen on the 2 ortho position, because this is electron rich, and this tertiary butyl group also have plus I effect. So after this substitution, the ring became more electron rich even. So that's why the substitution will happen and 2 nitro group will attach to this nucleus. So this is the thing. Now question, why not this position? Because this is meta with respect to this OMe, that's why. And you can say that, sir, ortho with respect to this tertiary butyl is true, but remember student, first of all, tertiary butyl is a big group, so nobody likes to stay closer to this big one, tertiary butyl group. Second, plus R effect is far more stronger than plus I effect, so that's why reaction will stop here. Now, what are the key steps and main reaction associated with this process? First step is ether formation by SN2 type reaction. As I told, first O minus, then nucleophilic attack, but which is actually SN2 type reaction. Second step, this is Friedel-Crafts alkylation, and in this case carbocation is generated by protonation, and the proton comes from sulfuric acid, which is a very strong acid, and in this case carbocation is significantly stable because it is a tertiary carbocation, and tertiary carbocation have 3 plus I effect and 9 hydrogen to which can participate in hyperconjugation. So that's why tertiary carbocation is very stable, even it's more stable from benzylic carbocation. I have already discussed a dedicated lecture. Now third one is this will produce an OMe is orthopara orienting and activating, and that's why it undergoes this nitration by nitronium acetate. So this is the structure, 3 key steps of this problem. Now what is the answer? Answer is option B. Okay, now student, you may think that's it's a too long problem, too difficult. Why did you say it that it's a very easy problem? Student, actually it's very easy problem. Why? If you look at the first step is easy methylation, and if you are able to draw the structure 2-methyl propene and sulfuric acid, what it produces? Tertiary butyl cation. Simple, just this much. Now tertiary butyl cation will be added. Look at the option C and option D. In this case acetyl, no tertiary butyl, gone. This is isopropyl, no tertiary butyl, gone. What is left, student? This is second, that this tertiary butyl group, where it can got attack. So 2 options possible, to ortho or para, because with respect to OH, here it is attached to meta, so not possible. Now you can see what is left, so this is the answer. Remember student, examiner gives easy question, but you need to understand in which point it is easy, what is the tricks. The tricks for this problem is, means the strategy you can solve with less than 30 seconds is, first understand that it is a OMe formation from OH to OMe phenolic derivative. Second, in para position this will attach. Where is the option given? So that's why in case of MCQ question, first you should look at the problem, then you should look at the answer, which answer is getting closer, and then mark them. Which is completely illogical, just cross them, means these two. This is called process of elimination. If you follow this process of elimination, then life became easier to solve those MCQs. So this is the end of the discussion. So in conclusion, what you have learned today: phenol is actually an electron rich aromatic compound, and it is orthopara orienting and activating. Okay, in ortho position both minus I and plus R. Please remember minus I and plus R works, but in para position only plus R operates. Finally, direct nitration of phenol may result in oxidation of the ring because the phenol is electron rich compound, and second, nitric acid is strong acid, but along with that it is oxidizing also in any condition, dilute or constant, whatever you consider. So that's why it is needed to convert this phenol into ether or ester derivatives such that the possibility of oxidation of this benzene nucleus could be reduced. Okay, so this is the end of the discussion. I believe this video may be useful. If it is, please help this channel to grow, and I request you, if possible, please visit my another channel, Climate and Chemistry, where I upload global warming and climate change related videos. Stay happy, stay blessed. See you in my next video.